Hello to everyone. Today we are going to see flip-flops. SR, JK, D and T. SR flip-flop. This circuit is used to store the single data bit in the memory circuit. So the SR flip-flop has a total of 3 inputs. Example, S and R are the current output. Q, this Q is the output. This output Q is related to the current history or state. The term flip-flop relates to the actual operation of the device, as it can be flipped to a logic set state or flopped back to the opposing logic reset state. The set state, the input R is set to false or 0, and the input S is set to true or 1. The NAND gate Y has an input 0, which will produce the output Q-1. The reset state, R is equal to 1 and S is equal to 0. One of the inputs of NAND gate X 0 and its output Q is 1. This is the characteristic table. JK flip-flop. The JK flip-flop is basically a gated SR flip-flop with the addition of a clock input circuitry that prevents the invalid output condition that can occur when both input S and R are equal to logic level 1. Due to this additional clocked input, a JK flip-flop has 4 possible input combinations: logic 1, logic 0, no change, and toggle. This is a truth table. D flip-flop. The D flip-flop are constructed from a gated SR flip-flop with an inverter added between S and R inputs to allow for a single data input. Then the single data input labeled D and is used in place of the set signal, and the inverter is used to generate the complementary reset input, thereby making a level sensitive D type flip flop from a level sensitive SR latch, as now S is equal to D and R is not equal to D as shown. It will store and output whatever logic level is applied to its data terminal so long as the clock input is high. Once the clock input goes low, the set and reset state of the both inputs flip-flops are both held at logic level 1. This is the table. T flip-flop. T flip-flop is a simplified version of JK flip-flop. It is obtained by connecting the same input T to both inputs of JK flip-flop. It operates with only positive clock transitions or negative clock transitions. Here, the inputs of JK flip-flop are considered as J is equal to T and K is equal to T in order to utilize the modified JK flip-flop for two combinations of inputs. Here, Qt and Qt plus 1 are represented are present state and next state respectively. So T flip-flop can be used for one of these two functions, such as hold complement of present state based on the input conditions when positive transition of clock signal is applied. This is a characteristic table. JK flip-flop. Now we are writing two switches, one clock signal, and one outputs to. We're connecting Q and Q dash to the outputs. Turning it on. You see bulb is glowing. Turning on switch 1. The first bulb is glowing. Q is outputting 1. Turning on the second switch. Q dash is outputting 1. And Q 0. As said in the truth table, we turn on both, then as the clock signal moves, we have output 1 and 0. T flip flop. Now we are connecting two switches, clock output, not gate. Starting this, connecting to this clock signals, getting to outputs, turning on the first switch. There are no outputs yet. So if we turn on the enabler, then we have Q dash as 1. We turn on the second switch, then we have as the clock signal goes, we have Q 0, Q dash 1. Turn on both, then Q is 1 and Q dash is 0. This is D flip flop. SR flip flop. And we're having two output switches, two input switches. Enabler, connecting Q, Q dash, turn on. We already have both are off. Then we have Q0, Q dash 1. We turn on the second one, it's the same. Q is equal to 0, Q dash is equal to 1. Turn on the first one, we have Q is equal to 1 and Q dash is equal to 0. We turn on both, we have Q is equal to 1, Q dash is equal to 0. T flip flop, writing the enabler, writing this to the switch, writing the switch to the T, directing the AND output there, writing this not output CLR, writing Q dash to the bulb and Q to the output bulb, connecting to the 1. Dash, labeling, turning on the enabler, turning on the second switch T. You see, we have when the clock is on, we get